Welcome to our short information event about exchange an old PQ analyzer to get a new PQBox 150, 200 or 300. Why it makes sense to replace an old power quality analyzer with the latest technology. For me, the most important argument is to measure superharmonics, to measure high frequency disturbances, because we're getting more and more high frequency emissions to our net electric grid nowadays. For example, if you work with solar inverters, they normally work with a sampling frequency of 16 or 18 kilohertz. Or if you want to analyze the interference of electric cars, the electric car could have an interference between 10 kilohertz up to 80 kilohertz. And if you want to measure superharmonics, there's always a rule. The sampling frequency of a network analyzer must be at least twice as high as the frequency you want to measure. So any analyzer is limited at least at 50% of his sampling frequency. And to show one example, I've made a measurement in a low voltage grid and we get some interference with superharmonics. I make an oscilloscope snapshot with an old PQBox 100, and the PQBox 100 is working with a sampling frequency of 10 kilohertz. So we see a perfect sinus without any disturbances. I make the same snapshot with the PQBox 200, and here we are working with a sampling frequency 4 times higher with 40 kilohertz. And with 40 kilohertz, you see a ripple over the fundamental frequency. And if we make an FFT spectrum of it, you can analyze there is a superharmonic at 5 kilohertz. The highest is 10 kilohertz with about 1.7 volt, little bit 15 kilohertz and 20 kilohertz. So all the superharmonics can't be seen from a PQBox 100 or older devices with a sampling frequency of about 10 kilohertz, for example. So here is a range of all of our analyzers, and it's clear with a higher number of the PQBox, the sampling frequency is higher, and we are looking in a wider spectrum. Up to 200 kilohertz is possible. So with the PQBox 150, here we're working with a sampling frequency of 20 kilohertz. So we can analyze disturbances in the grid up to 10 kilohertz. So with the PQBox 200, the sampling frequency is 40 kilohertz. So we are limited up to 20 kilohertz to see disturbances of voltage and current. And our high-end analyzer is a PQBox 300, and here we can measure online up to 200 kilohertz, and permanent recording of all the superharmonics we have up to 160 kilohertz. So what are the problems with superharmonics or high frequency in the network? So one of the reasons is maybe a malfunction of other devices. So other devices working with small signals, and if a high frequency going to this device, it can stop or start, or you have any wrong operation. The next phenomena could be an acoustic problem, that you can hear maybe a 4 or 8 kilohertz out of other devices. And one of maybe the worstest disadvantage of superharmonics is the overload of other devices and the reduction of lifetime. So often with high frequencies, the current increases, so the heat and the losses increases, and this means at the end often it's reduction of the lifetime of this device. Many standards react and establish limits up to 150 kilohertz. So we have a problem. We produce superharmonics coming more and more, and now we need also limits for the normal standards. One of the standard I often use is the 61000-2-2, And here we have limits for superharmonics since 2018 up to 150 kilohertz. The next standard, which is coming this year, is an international standard for industrial area, the 61000-2-4, and also here you will find in future limits up to 150 kilohertz. So from the analyzer, it's a need that you measure also the limits up to 150 kilohertz. And then you find national and international, many other standards who increase the limits in higher frequency ranges. Here's one example. I measured an electric car. It's an ID bus from Volkswagen. And here we see the output of a PQBox 300. We measure in a 200 Hertz bandwidth from 9 to 160 kilohertz, all the spectrum permanent over 1 week or longer if you want. And here this car is not producing a big interference, but you can clearly analyze that there is an interference of the electric car about 36 kilohertz. If you measure a lot of data, it's a must that the software is powerful and tells you what is interested in all your data, because only with superharmonics we measure more than 6,000 parameters permanent. So you're helpless with all the data, but with nice graphic tools, you can analyze which frequency you find at which day or daytime and nighttime. And now maybe we analyze, okay, the 16 kilohertz and the 32 kilohertz I'm interested in. And now I'm looking to the time level diagram. A nice feature is a VLAN interface of all our boxes. So sometimes it's interested to do not open the cabinet and you work with remote without establish a cable connection directly with your device. Or you install a PQBox on a pole-mounted transformer station. You do not want to climb up, so it's easy to read out, to communicate with the PQBox wireless. We have a nice app for Android operation system and also for the Apple operation systems. You see all the online data, often with a high resolution of your smartphone. You see the online oscilloscope waveform. You see the bar graph of all harmonics with the limits also included in the same picture. The phasor diagram, the load, the power, the energy, a lot of data you can analyze directly with your smartphone coming from the analyzer. And the second feature is you can do all the settings also of a PQBox. It's not a must that you connect your PC, your software to the device. You can easily do all the settings with your smartphone. All our analyzer measure 4 times current and 4 times voltage, but sometimes I need to measure other signals parallel to the power quality. So sometimes it makes sense that I measure the temperature in a cabinet parallel to the power quality. Maybe some components getting problems with heat and not with the power quality. Or I measure the load of a transformer and also the heat of a transformer parallel with one measurement. Or at the aux input, I connect a differential current clamp and I measure at a RCD the residual current, and I also can trigger on the current and find out when the RCD is tripping. What is the reason for it? Or another example, maybe at a big electric pump, I want to measure voltage and current and the load. And from the output of the flow meter, I measure this parallel to the load of the pump. So there are endless possibilities to use a PQBox and additional the aux input for other signals. One feature I often use in industrial application if maybe a big plant or machine sometimes stop running, I want to find out, is a problem coming from the network or do we have internally a problem? So the easiest way to find out what is a problem for this machine is to search for any voltage signal which you're losing if the machine stop running. And you always find a 24 volt DC, 60 volt DC, 230 volt AC signal. You can connect any voltage signal to the binary input of the PQBox. And if the machine stop running and you have a problem, you can set up the PQBox that you have up to 600 seconds pre-time. So in a high resolution, we can look back 600 seconds with the disturbance recorder. What happened? Why does the machine stopped? And here was a nice story. A big machine permanently stopped running, and the reason was a really small voltage dip. And we see a voltage dip only about 2 volt. And no analyzer normally trigger on a voltage change of 2 volt. But we trigger here on a binary output of the machine. We see here the problem. The machine goes down. You see it on the current. And we look back. And here we can prove that the network is not responsible or the reason for tripping this machine. High transients. If you measure fast transients, it's a must that the analyzer sample as high as possible. And here we find a transient recording out of a PQBox 200. And here we can have a sampling frequency up to 4 megahertz. So it's really, really fast. To measure the reason of harmonics and who is responsible, who is producing the harmonic in your grid is not so easy. And in our latest PQBoxes, we have many, many different possibilities to analyze the reason for harmonics in the network. And one is we measure the direction, the load flow of the harmonic, but additional, we have many, many other possibilities. So like here, we measure the fifth harmonic produced from an office. And at the office, we have also some electric charging stations. And also these producing the fifth harmonic. But you see the phase angle of the two measurement points is in the opposite direction. So both producing the fifth harmonic, but both together at the transformer, the load is much smaller than a single device is producing here. So we have different possibilities to analyze the angular position of all voltage and current harmonics to see if a customer connected to the grid is positive for harmonics or negative. So it's the same here in our online measurement. We have it online and offline. Yellow means this is a voltage of the 11th harmonic at the moment in the grid. In the green arrow is a current with the angle compared to the fundamental of the voltage. And if these are close together, you can imagine that this customer or this device has negative effect on the 11th harmonic because he will increase this level in the network here. The other effect we have on the 7th harmonic, the disturbance of the grid is here, and this device with about 75 amp of the 5th harmonic is producing in this angle position. You can imagine that if this device is running or big plant is running, it's a positive effect on the 7th harmonic at this point. So if you're interested in more information about superharmonics or the phase angle we calculate for harmonics, please have a look to our webpage. You'll find many technical articles and many video clips to explain our features and explain also these technical problems. So what are the conditions for the exchange campaign? So the exchange campaign started yesterday and lasts till end of this year. So if you order a PQBox 150 and you destroy or send back an old analyzer, you get 500 euro discount. For PQBox 200, you get 600 euro, and for PQBox 300, we grant 750 euro. So 3 simple steps to take part. Please send your order of your PQBox to your sales partner and tell him that you take part in the exchange campaign. Then to make it as easy as possible for you is don't send the device back to us. For us, it's okay if you send us a photo that you prove that you destroyed the device, that you can't use this device anymore. I show it here in one example. If you order a new PQBox, send 2 photos together with the order, 1 photo of the serial number of your device and 1 photo that you show us you destroyed the display, you cut off the measuring leads. It's up to you to show us that you destroyed this device. For 1 PQBox, you can send back or destroy 1 old device. And if you get your bill, we automatically reduce the discount I mentioned here on your bill. If you have any questions about this campaign, please send an email to us. We can explain it. Thank you for your interest and have a nice week.